we will start part 2, immune molecules. Okay, let's study chapter 2, antigen. Antigen. Okay, everybody. Let's see what's definition of antigen. Of antigens. Okay. Um, there are there are different name of antigen. Example, uh, im, immunogen, 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 immunogen in Chinese 免疫元，免疫元. Okay, that means any substance uh, capable, capable of inducing an immune response and is said to be immunogenic. Okay, all immunogens are also antigen, are also antigens. Okay, another name is toler, tolerogen, tolerogen. Okay, tolerogen in Chinese 耐受元 Foreigness in Chinese 耐受元 Okay, that is an antigen can induces immunological tolerance. Immunological tolerance. Okay, another name is allergen. Allergen. Allergen in Chinese 变应元 Allergen in Chinese 变应元 Okay, allergen is an antigen that elicits an immediate hypersensitivity. Hypersensitivity. Okay, so we know the antigen in Chinese 抗原 antigen in Chinese 抗原 Antigen are substances that are recognized by a particular immunoglobulin or TCR, and so can serve as the target of an immune response, are called antigen. Okay, the antigen is very important for immune response because it can serve as a signal to induce, to induce, to to invoke the immune response. They have two abilities. They have two properties. They have two properties. Okay, immunogenicity and immunoreactivity. Okay, the immunogenicity in Chinese 免疫原性免疫原性 Okay, immunogenicity in Chinese 免疫原性 Okay, that's an ability of antigen which can stimulate one individual to evoke a specific immune response. Uh, okay, that's called immunogenicity. Okay, another properties of antigen is immunoreactivity. Immunoreactivity in Chinese 免疫反应性. Okay, that is an ability of antigen which can combine specifically with corresponding antibody or effective T lymphocytes. Okay, buddy. Uh, let's see the figure. Okay, the figure shows the immune the immune response. The immune response evoked by the antigen. This is the adaptive immune response. 适应性免疫应答 adaptive immune response. Okay, based on the ability to carry out these two functions, antigen may be classified into different types. Okay, heptin, 半抗原 heptin. Okay, the heptin only possesses immunoreactivity. It can it cannot evoke the immune response by itself. Okay, most of the heptans encountered in nature are small molecules. Example, penicillin. Penicillin. Okay, they are heptan. They are heptan. Okay, it become immunogenic on combining with a large molecule carrier. Okay, the carrier can enhance the immunogenicity of heptin. Okay, so there are two antigens, complete antigen and heptin. Complete antigen possesses both two properties, immunogenicity and immunoreactivity. But the heptin only possesses immunoreactivity. Okay, if heptin combine with carrier, it can become complement antigen. Okay, now let's see section 1. Foreigness and specificity of antigen. Foreigness and specificity of antigen. Okay, the substances in nature, the substances well precise, well evolve the immune response. They must be foreigness and specificity for the body. Okay, foreigness, foreigness, foreigness in Chinese 异物性 foreigness. Foreigness means non-self substance 异物性 Okay, that means substances which never contact with uh, inorganic lymphocytes according to Burnett series. Burnett series. Okay, the immune system normally discriminates between self and non-self, so that only molecules that are foreign to the host are immunogenic. Immunogenic. Okay, so mm, not all all of substances are antigen for our body. Uh, they are must be foreigners. They are must be foreign to the host. Okay, so it can serve as antigen to evoke the immune response. Okay, the another most important the 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 another most important is specific specificity specificity specificity. Okay, the specificity exists in both immunogenicity and immunoreactivity, and is the basis of immunologic diagnosis and immunological therapy. Therapy. Okay, everybody look at the figure. Okay, the figure shows the combination of antigen with antibodies. Antigens with their corresponding antibodies. Okay, only the antigen confound with its corresponding antibody. Okay, that are called specific. Okay, that is the basis of immunological diagnosis and immunological therapy. Okay, let's see. Let's study a, a definition. A definition. Epitope. Epitope. Okay, what is epitope? Epitope. Epitope. Epitope is small, particular chemical groups existing in antigen which can be recognized by TCR or BCR or antibody. Antibody. Okay, when a single pure protein serves as an immunogen, the response is usually directed against only a few discrete clusters of amino acid residues within the larger polypeptide. The specific site of chemical feature that is recognized by a given antibody or TCR is called an epitope, or in older terminology, an antigenic determinant. Antigenic determinant intermediate 抗原决定处 Okay, it follows that every immunogen must contain one or more epitopes that enable it to serve as an antigen. Not all antigens or epitopes are immunogenic. However, in other words, not every chemical substance that can be bound by an immunoglobulin or TCR is. by itself, capable of inducing an immune responses. Okay, you know, the epitope can determine the specificity of the antigen. Okay, for polypeptide antigen, okay, only two, only 5 to 23 amino acid residues can consist epitope. Okay, for polysaccharide antigen, only 5 to 7 monosaccharides. Okay, for nucleic acid antigen, even 6 to 8 nucleotides. Nucleotide can consist of an epitope. Okay, so it's very magic. It's very magic. It's so magic. Epitope just is small particular chemical groups existing in antigen which can be recognized by TCR or BCR or antibody. Okay, so epitope can decide the specificity of the antigen. Okay, a subtle change of epitope. Example, characteristic number and conformation can influence the specificity of antigen. And then we know the epitope is the combined site of antigen to antibody. Okay, the 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 figure shows the chemical component arrangement and conformation affect the specificity of antigen. Okay, so you know that is magic. That is magic. The the very small residues can decide can decide the can decide the specificity of the antigen, and also that is the site of the combining that is the combining site of the antigen to antibody. Okay, this is the classification of epitope. Okay, you know, according to the size and the structure of antigen determine, uh, uh, according to the size and the structure of epitope, it can be classified into conformational epitope and sequential epitope or linear epitope. Okay, this is conformational epitope. Okay, conformational epitopes are formed by amino acid residues that are not in a sequence but become uh, spatially uh, juxtaposed in the solid protein. They are normally exist on the surface of antigen molecules. They are recognized by B cells or antibody. Okay, but the conformational epitope maybe lost its function after denaturation. After denaturation. Okay, this is sequential epitope. The epitopes formed by several adjacent amino acid residues are called linear determinants. They exist on the surface of antigen molecules or inside molecules. They are They are mainly recognized by T cells, but some also can be recognized by B cells. Okay, if the epitope is inside of molecules, okay, maybe they are non-functional. They are non-functional. 没有功能 they are non-functional. Okay, because they could not be recognized by the TCR or by the T cells or B cells. Also, according to types of cell recognizing epitopes, the epitopes can be classified into T cell epitopes and B cell epitopes. Also, the T cell epitopes are usually a sequential determinant existed in any well of antigen. But B cell epitopes are sequential determinants or conformational determinants existing on the surface of antigen. Existed on the surface of the antigen. Okay, so according to the definition, we know the B cell epitopes are usually functional because they are existed on the surface of antigen. It can be recognized by the T cell or B cell easily. Okay, let's study another phase of antigen. Okay, uh, in the nature, there are some common antigen and cross reaction. Common antigen. Okay, common antigen in Chinese, 共同抗原 common antigen, 共同抗原 Okay, that means the antigen have the same or similar determinant. They have the same or similar determinant. Uh, okay, called they can be called common antigen. Common antigen. Uh, okay, it's very easy to understand because the most of antigen is are protein in nature okay, the protein the protein is consists of amino acid. Okay, in fact, there are only um, there are only 22 amino acid in nature. In nature. Okay, so it's very easy to understand. The different proteins maybe have the same or similar amino acid residues. Okay, so they have the same or similar determinant. Okay, so they are called common antigen. Okay, there are another phenotype, phenomenon, cross reaction. Cross reaction. The antibodies induced by one kind of antigen can react with another antigen because of presence of common determinant between two antigens. Okay, let's see. Okay, let's see the figure. Okay, there are two antigens, antigen A and antigen B. Okay, we can see on the surface of the two antigens, they have same epitope. This one, epitope two, epitope two, epitope two. Okay, so the antigen evokes the immune response to produce anti-2, anti-2, anti-2. Okay, so you can see the anti-2 can react with antigen B, also can react with antigen A. Okay, the phenomenon is called cross reaction. Cross reaction. Okay, so you know the basis of cross reaction is the basis of the cross reaction are common antigen. Are common antigen. Okay, you know the significance of the cross reaction is uh, have two phases. One is normal, another is abnormal. Because there are some common antigen epitopes between different microbes, so anti-serum, the anti-serum against one kind of antigen can also react with another antigen and cause a cross action. Okay, you know, in clinic, existence of cross-action may lead to wrong diagnosis and autoimmune. Okay, everybody, the figure over a throat, over throat, over throat, over throat. That's the streptococcal throat infection. But because there are common antigens between hemolytic streptococci and over joints, heart, skin and nervous systems. Okay, so during the infection of hemolytic streptococci, also it can damage our joints, heart, skin, and nervous system. Okay, that is that is autoimmune disease caused by the reaction. Cross reaction. Okay, now let's see section 2. Let's study uh, the determinant of immunogenicity. Immunogenicity. Okay, the ability to evoke an immune response and the nature and the intensity of this response depend not only on the uh, physical the factors that influence immunogenicity are complex, but several important generalizations can be made. Okay, so the determinant of immunogenicity may be involved factors related to antigen, factors of host, and the method of immunization. Okay, the factors related to antigens involve foreigness. Foreigness. Okay, the immunogenicity of substance is related to the degree of its foreignness. Of its foreignness. Okay, according to the degree of its foreignness, the 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 antigen the substances can be classified into three groups: exo, exo, exo substance, exo substance. Example: various passengers and their products. Ex- Xeno, sorry, xeno substances uh, include uh, various passengers and their products. Xenoproteins. Xenoproteins. Okay, the second group is allosubstances. Allosubstances. Example: ABO, blood type. HLA. HLA. Okay, the third group is self-components. Self-components. Okay, the self-component may be mutant cells of itself. Mutant cells. Mutant cells. And uh, denatured, denatured IgG. Denatured IgG. Okay, certain physical and chemical properties also can influence the immunogenicity of antigen. Nucleic acid. Nucleic acids are larger than lipids. lipids. Also, we know aromatic ones are lighter than others. Also, one is lighter. One is better. If one structure is larger than uh, linear linear structures. Okay. Also, the molecular size and the uh, complexity also can influence the immunogenicity. Uh, reasonable large molecules, more stabilization. Okay, because they have more surface structures for lymphocytes to recognize. And then we know polymer is better than monomer. Particulate is better than soluble. Denatured is better than native. Also, the factors of the host can influence the immunogenicity. Uh, genetic constitution of the host animal, and its age and healthy condition. Okay, the ability to respond to a particular immunogen is genetically predetermined. For example, some strains of gene produce a vigorous antibody response against the central polypeptide. Only L-lysine, whereas other strains give no detectable response. Crossbreeding studies among these strains indicate that the ability to respond to poly-L-lysine is inherited as an autosomal dominant trait. Many analogous phenomena have been described in humans. Selective responsiveness of this type reflects a number of hereditary factors, the best understood of which include the particular collections of different immunoglobulins and TCR proteins that an individual is able to produce, and the ability of antigen presenting cells to present specific types of molecules to T lymphocytes. Individuals whose APCs cannot present a substance or whose lymphocytes cannot recognize it will not respond to these substances as an immunology. Okay, so the factors of host can influence the degree of the immune response. Okay, the the method of immunization also can influence the degree of the immune response. Okay, the dosage of antigen, times of injection, the route, the route, the route can influence. Okay, the subacute, the subacute, the subacute, the sub, the subcutaneous are is better than intravenous. Intravenous is better than oral. Is better than oral. Okay, so whether a substance will evoke an immune response also depends on the dosage and the route by which it enters the body. A quantity of substance that has no effect when injected intravenously may evoke a copious antibody response when injected subcutaneously. Route of the contact also can influence the uh, qualitative nature of a response. For example, an immunogen that contacts the uh, intestinal mucosa typically evokes the production of a different type of antibody than would be produced if it entered through the bloodstream, and it can affect subsequent events in the immune response. Okay, another factor, adjuvant. Okay, adjuvant is a certain substance which can enhance the immune response or change the type of immune response. Okay, buddy, let's have a rest. Have a rest for 5 minutes. For 5 minutes. Okay. On 11, we will continue. Okay. At 11, we will continue. Okay, buddy, have a rest. Okay, buddy, let's come back. Let's come back. Let's continue. Okay, 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 let's study the section 3. Classification of antigen. Classification of antigen. Okay, uh, according to immunogenicity of the antigen, it can be classified. It can be classified into comp- complement, uh, complete antigen and hapten and hapten. Okay. Um, Before we have studied the difference of the complete antigen between haptens. Between haptens. Okay, according to the rhizome need the help of T cells when B cells produce antibody. It can be classified into TD antigen. TD antigen. TD antigen means thermos-dependent antigen. And TI antigen. TI antigen means thermos-independent antigen. Okay, TD antigen can stimulate B cells to produce antibody with the help of T cells. But TI antigen stimulates B cells to produce antibody without the help of T cells and phagocytes. Phagocytes. Okay, let's see the properties of TD antigen. Okay, we know the most of TD antigen are protein in nature. More kinds of they have more kinds of determinants, less number of each kind. Okay, the TD antigen can stimulate B cells to produce antibodies. Example, IgG, IgM, and IgA, Okay, it can it can induce cellular mediated immunity. Cellular mediated immunity. Also, it can evoke immune memory. Immune memory. Okay, that means the TD antigen can evoke the secondary immune response. Okay, that is TD antigen. That is the properties of TD antigen. TD antigen. Okay, so uh, the most of TD antigens are protein. Also, the most of antigen are TD antigen. Okay, this is Ti antigen. Okay, the Ti antigen means thermos-independent antigen. Thermos-independent antigen. Okay, they can stimulate B cells to produce antibody without the help of T cell and phagocytes. Okay, in nature, most Ti antigen are polysaccharides. Most of Ti antigen are polysaccharides. There is more than repeated determinant. And then Ti antigen only can induce B cell to produce IgM, couldn't produce IgG or IgA, only to produce IgM. and then it cannot it can they cannot induce CMI. They cannot induce CMI, and then there are no memory. There are no memory. They have no memory. They have no memory. Okay, so the the response, the immune response are not different, are not different, evoked by the TD antigen and the TI antigen. Okay, everybody, you can see the figure shows the immune response evoked by the TI antigen and the TD antigen. Okay, the two antigen can evoke the different immune response because the activation of the two antigen are not same. Okay, the part we will learn the part later. We will learn the part later. Okay, if according to foreigness of antigen, it can be classified three groups. Xenoantigen. Xenoantigen. Example, most of microbes. Most of the microbes, and substances from the another strength, another strength, and the the second group is alloantigen. Alloantigen in Chinese 同种型抗原，同种异型抗原，同种型抗原。Okay, example, the the blood cell, the ABO antigen on the blood cells, and the MHC antigen on the different tissues from the different individuals, alloantigen, 同种型抗原。Xenoantigen, that means 异种抗原。Xenoantigen in Chinese 异种抗原。Okay, autoantigen 自身抗原。Autoantigen that means come from the body, come from the host cell, the host itself, example nucleic antibody, a nucleic acid antigen, the mutant nucleic acid antigen, or denatured antibody, that come from the host itself. Okay. Now let's see some important antigen in medicine. Okay. Some passengers and their products. Okay, they are xenoantigen. Okay, the passengers the passengers have different have different complements with with the human beings, with the human beings. Okay, so for the human beings, the passengers are the best antigen. They have best immunogenicity. Immunogenicity. Okay, the antigen on the surface of the passengers. Example: surface antigen, VI antigen, somatic antigen, abbreviated O antigen, flagellar antigen, abbreviated H antigen, and the pilus antigen. That is on the surface of the passengers. Okay, and then the best antigen come from the product, of the passengers. Example: exotoxin and toxoid. Exotoxin 外毒素 exotoxin in Chinese 外毒素 exotoxin is produced by gram-positive bacteria. It has strong immunogenicity and pathogenicity. It has strong immunogenicity and pathogenicity. Okay, the toxoid come from the exotoxin. Toxoid is toxoid uh, is a losses is toxicity. Toxoid is exotoxin, which loses its toxicity and maintains its immunogenicity under suitable conditions. Okay, uh, example, tetanus toxoid, tetanus, tetanus toxoid is widely used in the medicine. Tetanus toxoid. Toxoid in Chinese 类毒素。Okay, maybe the immune serum of any of animals, uh, uh, immune serum of animals maybe immunogen, maybe antigens for person, for human beings, Okay, the amino the 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 amino the amino serum contains antibodies. Okay, the antibodies can bind to antigen to protect our body, but the amino serum comes from other animal animals. Amino serum comes from other strains. Okay, so for human beings, they are immunogenicity. It can induce hypersensitivity. Okay, so we know the immune serum of animals. Animals have two phases. One is abnormal, another is normal. Okay, example: TAT. TAT is widely used in the medicine. TAT. TAT is tetanus antitoxin. 破伤风抗毒素。TAT usually comes from the horse come from the horse serum. Horse serum. Okay, so horse serum is the antigen for human beings. Okay, another important antigens, heterophilic and heterophilic antigen, uh, also called Foreigness antigen. That is a kind of common antigen are shared by different species. It's no specificity of species. Okay, such as Foreigness antigen. Foreigness antigen exists on the SRBC and the genial pig organs, and heart or kidney of human and streptococcus, heart or kidney of human and streptococcus. Okay, all 14 of E. coli and chronic mucosa. All 14 strains of E. coli and chronic mucosa, and OX19 of proteus, OX19 strains of proteus and rickettsia typhi. Okay, so because the heterophilic antigen are common antigen. Okay, so it can induce immunopathology and wrong diagnosis. Okay, about it, uh, that is the type 2 antigen. Okay, by the end of this lecture, uh, you should master, you should know the definition and characteristics of antigen, and the definition of antigenic determinant, conformational determinant, and linear determinant, or epitope. The differences between T cell epitope and B cell epitopes. Definition of common antigen and cross-reaction. Uh, Difference between TD antigen and TI antigen. And how can you classify different antigen? Okay, and then what is heterophilic antigen? Okay, you should know important antigens in medicine.